Good morning, everyone. I hope you are having a fantastic day today. We are going to be talking about compound interest in this note page. It's one of my favorite topics to talk about in Integrated 3 because it's one of the ones that is most important. Before we get into compound interest, though, I do want to mention where we're at. So I know that it says essential question 1. We are actually in essential question number 4, page 4. So in your yellow packets, if you turn to page 4, we are going to be taking both page 4 and page 5 notes today. So I apologize about the one there, but this was how we originally normally would start semester 2, but we're a little bit behind, so we're going to be using this as our 4th note page. So also before we get into compound interest, I do want to review some key concepts with you. So if you want to pause the video and try to do the top 2 problems on your own first, that would be great. And then what's going to happen is I'm going to walk you through really quickly how to do them. All right, so hopefully you paused the video. So let's look at the first problem. So the first problem, we have 2x minus 4 to the 3rd power. So first thing we have to do is we have to rewrite this 3 times. Do not ever distribute the exponent into the parentheses. That's not possible. The 3 tells me I have to write it 3 times. Now to multiply these out, we only want to multiply a binomial times a binomial. So there's 2 ways to do this, and I'm going to show you both. The first way is using distributive property. And distributive property just basically says that I'm going to multiply my first item to the 2 items on the second, and I'll multiply my second item to the 2 items in the second parentheses. And when we do that, we end up getting 4x squared minus 16x plus 16. And then what we're going to do is we're going to bring down the 2x minus 4, and now we're going to either distribute the 2x minus 4 into our trinomial now, or you can use your second method, which I don't know if you've ever seen this before, but this is the box method. So the box method is another way to use essentially distributive property, but to see it in a little bit more concrete terms. A lot of the times people struggle with making sure to remember to multiply every single item to every single item in the other set of parentheses. And so this way, when you're multiplying, you can clearly see that you have to distribute the 2x to everything, the negative 4 to everything to get your values. And then once you do that, you're just going to combine your like terms to get your final result here and your answer of 8x cubed minus 48x squared plus 96x minus 54. Now, down below you'll see got it, kind of got it, no clue. If you really had no clue, then you probably want to just, refresh yourself on multiplication of polynomials. If you kind of got it, then you're probably fine. Got it, then you are definitely in a good place. All right, so the second review problem is on graphing square roots. So the very first thing that I always told my students first semester is we have to identify our a, h, and our k. So our a here is -2, which means it's going to be a vertical stretch and a reflection. Our h is going to be 1, which means we're going to shift to the right, and our k is going to be 4, which means we go up. We always start with our h comma k. So our h comma k here is 1 comma 4. So we can place a point at 1 comma 4, and that's going to be our starting reference point. So notice from the origin we went right 1 up 4. Then because our a is -2, that means we're going to go down 2 to the right of that second point. So down 2 to the right. And then because this is the square root, we're going to start at our reference point of 1, 4, and we're going to go through the point of 2 comma 2, and we have our graph. Now the last thing for this review is we do have to state the domain and range. So our domain is, remember, all set of our x values, and our range is all set of our y values. And so our domain goes from 1 to infinity because it goes forever and ever to the right, but not to the left. Our range goes from -infinity to 4 because it goes forever and ever down, but only goes up to +4. Again, check the got it, kind of got it, no clue to let me know where you're at. Also self-reflection for yourself. This is important to know. We will be dealing with A, H, and K quite a bit the rest of the semester. All right, now let's get to the fun stuff. So the fun stuff is going to be compound interest. So what the heck is compound interest? So compound interest is a type of interest that earns interest. And that sounds really confusing, but if you watch the video in regards to compound interest, it will make it a lot clearer. In the video, they say this is essentially interest on interest, okay? And so basically what you want to think about it is that when you invest your money into whatever it might be, mutual funds, stocks, the market, you earn interest on the interest that you earned from the year prior. And so compound interest is basically how the rich keep on getting richer. And so the more money that you're able to put into the account, the more interest you're going to earn, and thus more interest the following year. And so there are 3 different types of formulas that we use to calculate compound interest. The first one deals with interest annually. So if we earn interest annually, we would use the equation P parentheses 1 plus R to the T power. And then if we earn interest multiple times through the years, meaning that it's compounded not just once, but several times throughout the year, we would use the second formula, P parentheses 1 plus R over N raised to the N times T. And I'll explain what P, R, N, and T represent on the next slide. All right, so the last equation that you need to know is PER to the T, and that sounds really confusing, but it's essentially when we have items that are compounded continuously. And this very, very rarely happens in investing, but it does happen when we are trying to approximate specific values, and so it is an important equation that we want to see. And I do want you to understand the difference between it being compounded continuously versus maybe daily, and see the difference between the two. Now here is where I'm going to explain the different values. So P stands for principal, so that is the amount that you initially put into invest. T stands for time, so how many years are you going to be investing it in? And if we ever do months, please know that then we'll have to do a fraction, because T in these formulas will always represent years, okay? R is the rate, which is the interest percent, but remember that we always have to convert this to a decimal. So for instance, if you see something like 3%, you have to move the decimal over 2 places, so it's going to be 0.03. And then N stands for the number of times it's compounded per year. Now remember that the first equation, you don't use any N whatsoever because it's compounded annually. So the very first thing when you're solving a problem for compound interest is that you want to figure out what formula you're going to be using. And so you want to highlight the key pieces of information. So let's look at the first example, example A. It says a person invests $3,500 in an account that earns 3% annual interest. How much will the person have after 10 years? So notice that there was nothing that mentioned it being compounded. So because there's no word that says compounded, I'm going to be using my first formula because there's no essential N needed. So there's not going to be multiplied or compounded multiple times. In retrospect, if you look at B, do you see how it says compounded semi-annually? So because it says compounded semi-annually, I would use the second equation. If it said it compounded continuously, I would use the third equation. So the wording of the problems is really key to understand. So after you figure out which formula you're going to use, then you want to make sure you highlight the important pieces of information, i.e. the principal, the rate, the time, and of course the N if you were going to be using the N. So this first one doesn't have an N, so we're just going to write the formula down that we're going to use. Now notice that our rate went to 0.03 because it was 3%. So we move that decimal place over 2 times. So all we're going to do is we're going to plug in our values. So 3,500 for our P, 0.03 for our rate, and 10 for our time. And then what you'll do is you're going to plug this into a calculator. I do not recommend using your phone unless you're using the Desmos app. I highly recommend using the Desmos app or Desmos online. It will give you the correct answer, and you should be getting $4,703.71. If for some reason you didn't get that number, then you really want to make sure that you are plugging everything in correctly into your calculator, okay? So the next problem, it's the same thing. We've already established it's going to be the second equation, so we're going to highlight our key pieces of information. So it says a person invests $600 in an account that earns 6.25% annual interest compounded semi-annually. How much interest will they earn in 5 years? So again, we're going to start with our key pieces. So we have our principal of 600, our rate of 0.0625, our N of 2, and our T of 5. Now, for those of you that are like, wait a minute, Ms. Strickland, where are you getting this N of 2? So there are key words that you probably should know when it's compounded, okay? So if it's compounded annually, it's going to be an N of 1. Semi-annually is 2. Quarterly is 4. monthly is 12, and daily is 365. And lastly, continuously is E. And you'll notice the E in the third equation there. And so no need to actually insert an E here. It will always just be a separate equation for it. And so I would definitely highlight these if you're not familiar with the terms of semi-annually, quarterly, and so forth. And then what we're going to do is we're just going to go ahead and plug in our values again for P, R, N, and T. And just like the first problem, if you're using Desmos calculator or Desmos app, this should give you $816.19. Okay. And so please double check your calculator. Make sure you're getting the right answer. The one thing that you have to be careful also is what will the question ask? So this is how much interest will they earn? So this is their total balance. So in 5 years, their balance will be $816.19. The question though is how much interest will they earn? And so because it's how much interest, you're going to have to take your total amount that you have subtracted from your initial investment. And so for the interest, you're actually going to be having $216.19. Okay, so just be careful on what the question is asking you. So what we're going to be doing for the second half is we're going to be going through the problems fairly quickly. Okay, so what I would really encourage you to do is before you watch the video is I would ask that you try C through F on your own and try to work out the whole problem first and then check the video and see if you're doing it right. Practice makes for the best way to understand these problems, and we will be covering them in class as well, but again, the more that you do it on your own, the better. Okay, so here's the next slide. What I've done to start off with is I've taken C through E and I've highlighted all of the key pieces of information and I've rewritten them down. So I've identified what is my P, what is my R, what is my T, what is my N. And so any information that I know, I'm writing that down. That's going to be your first starting place. Then the second thing you're going to do is you're going to identify which formula you're going to be using based on the wording of the question. So go ahead and if you haven't tried that, pause the video, try it, and then I'm going to be showing you the answers right now. Okay, so you'll notice that you have two compounded continuously using the PERT, and you have two that are compounded for specific time frames. And you can identify that because of the specific words that I've highlighted. So anytime you see the word continuously, you always want to use the PERT formula. And anytime it says compounded for a specific amount of time, you want to use the P times 1 plus R over N to the NT power. So the next thing that we're going to do is we're going to go ahead and insert all of these numbers into our equation and actually calculate what our total investment is going to be at the end of the time frame that they're going to give us. Okay, so hopefully you are getting the same answers as me, or what you see on the screen. So you'll notice that essentially what I'm doing is I'm just plugging in the values for each of the equations. So most of the questions just asked us how much we're going to have in total. So the first question says how much money will the person have after 25 years? So they actually have a pretty hefty sum. They have $1,568.60, so pretty good. Now notice that it is compounded continuously, so very probably unrealistic, but you never know. D is a little bit confusing because it actually just says for you to write an equation. And the reason why you can only write an equation is because they do not give you T. T is unknown. So we've had to leave it in our equation just as T. The reason why this is important to be able to set it up is for the second part of letter D. Now notice that they've changed it to quarterly instead of monthly that they had before. And so although it's the similar setup, the N changes to 4, and so you'll have 4 times 15 because now that you've given us the actual time frame. And so we should have $7,598.68 after the 15-year investment. And then lastly, again, very similar to C, but notice that they asked how much interest will you have after 25 years and not your total. So in total, we'll have $239.89, but in interest, we'll only have $139.89. All right, so I wasn't able to project the very last problem, but I did want to share it with you here. I hope that you tried letter F as well. We have all of our key pieces of information. It is compounded continuously, so we are going to be using that PERT formula, and your answer should have been $2,416.50. Now, what I'd like you to do at the end of this note page is to evaluate how you are feeling about these types of problems. If you're feeling like, oh my gosh, Ms. Strickland, I am totally screwed. This is not cool. I don't get this. Please, please, please let me know in class. And so I'm going to be able to help assist you and we can do more practice problems, because the more problems we do of this, the better that we're going to be able to do these problems. If at this point you feel good, you can go ahead and pause the video, give yourself a pat on the back. The last thing I am going to cover is this real world challenge. One thing that I wanted to mention before we do this real world challenge is this is not going to be tested, but it's just something that is important to kind of understand how to solve problems and look at them. And so I thought it was important to bring it to your attention. Okay. So let's do this real world challenge, guys. Okay, so suppose a friend tells you she paid a total of $16,368 for a car, and you'd like to know the car's list price. So essentially the price before taxes. So you compare prices at various dealers, find the list price of the car if your friend bought the car in Arizona, which has a sales tax of 6.6, or California, which has a sales tax of 7.25. And it does give you a hint, use principal times 1 plus rate, okay? So we know our rates, but what we're trying to find is the principal, which is the list price. And so this is where it gets a little bit tricky, is a lot of my students think the principal is $16,368. That's not the case. That's actually the end result. So when you set this up, what you're going to do is you're actually going to have your equation equal to the car price at the end of the value. So for instance, we're going to be finding our P, because that's what we need to know. And so when we're setting it up, we're essentially kind of setting it up like an equation to solve. And you can set up the California one just exactly the same, except the difference with the California one and the Arizona one is that your rate is going to be different. So we're still solving for P, but instead of the 0.066, we're going to have 0.0725. Okay. Now, when we're solving this, the first thing you want to do is you want to combine your like terms, and your like terms are the 1 plus the 0.016. So if we combine those together, we would end up having 1.066p. I usually like to move my variable to the end. And then all we would have to do is just divide by the rate at this point to figure out how much the actual car cost. And so if we did this, our list price in Arizona would be $15,354.59. So kind of a lot of interest that, or not interest, but kind of a lot of tax that they had to pay on it. Almost $1,000, which is kind of crazy. We can do the same thing with California and see what the list price is in California. And we would do the same steps. We would just divide by the rate. And so the list price in California is very similar, $15,261.54. Again, you paid a little bit more in taxes, and that's why a lot of people sometimes buy out-of-state cars because they don't want to pay so much in taxes for a specific state. Well, I hope that you've learned a little bit about compound interest and you feel pretty good about it. But again, if you don't, remember to reach out to me and I will definitely help you throughout the semester. Have a great day.